Hello, this is Mrs. Edwards, and we are going to do the closure questions for Chapter 7 in the CCG book. So we're going to take a look at 7-147 all the way through 7-156. So looking at 7-147, Julius set his hinged mirror so that its angle was 72 degrees, and the core region was isosceles as shown below. How many sides did his resulting polygon have? Well, if we remember, our entire circle is 360 degrees. So if we take 360 and we divide it by 72, we get a 5-sided figure. What is another name for this polygon? Well, a 5-sided polygon we call a regular pentagon. Seven 148, Kelly started the proof below to show that if line segment TC is congruent to line segment TM and AT bisects angle CTM, then CA is congruent to MA. So TC is congruent to TM and AT bisects angle CTM. In the first column of our statements, we can justify that or give the reason that it was the given. Statement 2 says the reason for our statement is definition of bisects. So when we said that AT bisect CTM, it told us that angle CTA must be congruent to angle MTA. Statement 3 says AT is congruent to AT, and we know this because of the reflexive property. And prior to this chapter, we called it a shared side. We then can conclude that we then know that triangle CAT is congruent to triangle MAT based on the side angle side congruency. And our last and final thing is if we prove that triangles are congruent, which we did in the previous statement, we know that their parts are congruent. So we can make our final statement that CA is absolutely congruent to line segment MA. Closure question 7-149 says examine the spinner at the right. Use the spinner e-tools with labels to create spinners to test your ideas. But for today, we're going to use the spinner to the right. So the first thing they want us to find is find the expected value of the spinner if x is equal to 4. So if x is equal to 4, to find expected value, we take the probability times the number in the probability of that piece times the number on the spinner, and we add them all of our pieces together. So in this case, if x equals 4, we have 4 times this section right here is 90, which if we take 360 minus 135 minus 90 will give us 135 degrees. And if we take 360 and divide it by 135 degrees, the probability of spinning that section is 0.375. So we're going to take 4 because that's the number that they wanted us to evaluate for. We're going to multiply it by the probability of spinning that section on our spinner. We're going to add it to the probability of spinning the numbers on the other sections. And when we add those all together, we get the expected value of 4.5. So this time we're going to try it again, but we want the expected value for spinning a -8. So we're going to take 16 times the probability of spinning a 16, which is 0.375. We're going to add that to -12, and the probability of spinning a -12 is a 1/4 chance, 0.25, plus the probability of spinning a -8 is 0.375. When we multiply and then add all of those together, we get the expected value of 0. Letter C says, find x so that the expected value of the spinner is 6. So looking at our spinner, this time they told us the expected value is 6. So that is our output essentially. And we need to solve for what x is. So if we take 16 times 0.375, add that to -12 times 0.25, because that's only 1/4 of our circle, plus 0.375 times our x. We use our inverse operations. We would get x to equal 8. Closure question 7-150, ABCD is a parallelogram. If A is at 3, -4, so if we sketch our axes, and we have 3, -4, and we label that point A, 6, 2, and that is B, and C is at 4, 6, they then asked, what are the possible locations of D? Draw a graph and justify your answer. So when we talk about parallelograms, they could be multiple shapes. We could have a parallelogram states that we have 2 sets of parallel sides. So when we connect C to B, we can draw a slope triangle to know that we fall 4, so down 4, run 2. So our slope's -4/2. If our slopes are the same, so in this case, if we rise 4 and go backwards 2, we could have an ordered pair at 1, 0 would be a solution to create a parallelogram. For each diagram below, solve for the variable. So looking at 7-152A, I know that I'm working with a right triangle. I'm talking about this angle right here, which tells me that this leg of my triangle is my adjacent side. This is my hypotenuse. The trig function that uses adjacent over hypotenuse, so TOA, is cosine. So if I take the cosine of 42 degrees, it equals my adjacent side, which is x in this case, over my hypotenuse of 10. The inverse of division is multiplication. 10 times the cosine of 42 is about 7.43. Looking at my next triangle, I know that I have an isosceles triangle, 25 and 25, because my base angles would be the same. So when I subtract that from 50 from 180, I know that my upper angle is 130 degrees. I can then use my law of sines, so I can set up a proportion and put 15 over the sine of 130 degrees and set that equal to the sine of 25 degrees over x. When I cross multiply and divide, I would get x is about 8.28. Looking at example C, I am looking for an angle. So shout out to all my geometry friends. Whenever I am looking for an angle, I need to use inverse trig. So on your calculators, that's when you are going to push the second button. This 10 is opposite of my angle. This 18 is my hypotenuse. Sine uses opposite and hypotenuse. So the sine of angle theta is equal to 10 divided by 18. So in your calculator, you are going to push the second sine button, and it's going to say sine to the negative first power. It's going to give you a parenthesis. You're simply going to type in 10 divided by 18, and it is going to tell you that theta, or the angle, is about 33.7 degrees. Question 7-153 says, on graph paper, draw quadrilateral MNPQ if M is 1, 7 over 1 up 7, N is negative 2, 2, P is 3, negative 1, and Q is 6, 4. It then said, find the slope of MN. So when we look at the slope of this line, we are asking ourselves, how many did we run and how many did we rise? So we ran 3 units and we rose 5 units. So the slope of MN is up 5 over 3, excuse me. When we look at NP, we went down 3 over 1, 2, 3, 4, 5. Down 3 over 5. So the slope of line segment NP is negative 3 over 5. What can we conclude about the angle of MNP? Well, we conclude that this is a right angle because our slopes are perpendicular. What is the best name for MNPQ? Justify your answer. So when we continue all of these and look at all of these slopes, we will find that each line is made up of perpendicular lines. which form right angles, so we can state that it is a square. Which diagonal is longer? Explain how you know your answer is correct. Well, the diagonals of the square are equal. We could find that out a couple of different ways, but the easiest is to probably find the distance of the side of our square, the length of the side of the square, by using the Pythagorean theorem. So 3 squared plus 5 squared would give us our hypotenuse, or the side length of our square, squared. We then could use those side lengths, so 9 plus 25 gives us 34, the square root of 34, and then we would square both of those in order to find our diagonal. Square root of 34 squared plus the square root of 34 squared, which would give us, the diagonal would be the square root of 68 units long. Then it asked for the midpoint of line segment MN, and we could simply do that by looking at MN, and M, the ordered pair was 1, 7, N, the ordered pair was negative 2, 2, so 1 plus negative 2 divided by 2 would tell us that the x value of our midpoint is negative 1/2. When we look at 7 plus 2 divided by 2, it would tell us that the y value is 9/2. So the midpoint of MN would be negative 1/2, comma 9/2. Closure problem 7-154. Examine the geometric relationship in each diagram below. For 1, write and solve an equation to find the value of the variable. Name any geometric property or conjecture that you used. Well, looking at these two triangles, I can tell that this side is congruent to this side, which tells me if I look at the smaller triangle, it is half the size of the larger one. So I can take 2 and multiply that by 3m plus 5, and that should equal my base of 5m plus 11. When I solve this, 6m plus 10 equals 5m plus 11. I use my inverse operations. The opposite of addition is subtraction. In both cases, I would get m is equal to 1. Looking at B, PQRS is a rhombus with a perimeter of 28 units. PR is 8 units. Find the length of B. Well, I know that these two pieces of my rhombus should be 4 and 4, and I know the perimeter of my rhombus is 28. So a rhombus has 4 congruent sides, so the first thing I would do is I would divide 28 by 4, which would give us 7. So each side of my rhombus is 7 units long. So to find the length of B, I would use the Pythagorean theorem. 4 squared plus 7 squared equals our, in this case, B squared. So 16 plus 49 equals B squared. So be really careful that you didn't make the mistake that I made. And this 7 right here is actually our hypotenuse. So we have 16 plus b squared equals our 49. So these were in the wrong place. Use your inverse operation of subtraction. So when you subtract your 16, you get b squared is equal to 33. Take the square root of both sides, and you get b is approximately 5.74 units. Looking at example C, you can conclude that because we are talking about parallel lines, that this angle corresponds to this angle, which means it's also x minus 5 degrees, and these two angles form a straight line, so 3x plus 17 plus x minus 5 needs to be equal to 180. When you combine your like terms using inverse operations, you get x is 42 degrees. Looking at the last polygon, we can see that this side, quadrilateral, this side is congruent to this side. This side is congruent to this side, which means that our angles here and here should be congruent. So we can set 2x minus 5 is equal to x plus 13. When we use our inverse operations, we get x is approximately 18 degrees. We then could plug that back in to find the actual degree of our quadrilateral if we needed to. Question 7-155 gives us a diagram below and asks us to prove that triangle WXY is congruent to triangle YZW. So I'm going to go ahead and put triangle WXY is congruent to triangle YZW at the bottom. And I know I'm trying to come up with some congruent triangles to, in fact, state that these two triangles are equal. Looking at my picture, I know that angle WXY is congruent to angle YZW. And I know that because that information was given. So don't forget to put your justification. I also am given that line segment WZ is parallel. So line segment WZ is parallel to line segment XY. So that was also given from our picture. Looking at my picture, I recognize that WY is a shared side, so I can say that WY is congruent to WY based upon the reflexive property. So I now have an angle and a side, and I need to state one more thing is congruent in order to prove my triangle's congruent. So knowing that WZ is parallel to XY, I know that this angle is congruent to this angle because they are alternate interior angles. So because those lines are parallel, it tells me that angle ZWY is congruent to angle XYW. My justification is because they are alternate interior angles. And we know that when lines are parallel. So we now can conclude based upon angle, side, congruency that triangle WXY is congruent to triangle YZW. Looking at our last question, 7-156, it is another must be, could be. So here are some more challenges from Mr. Quincy. For each of the descriptions of a quadrilateral below, say what special type of quadrilateral it must be or what special type of quadrilateral it could be. Remember, some of the descriptions may have no must be statements and some descriptions may have many could be statements. So looking at A, it says the diagonal of my quadrilateral are equal. Well, I know that it could be, if I have equal diagonals, it could be a rectangle. It could also be a square or an isosceles trapezoid. Just by knowing that the diagonals of my quadrilateral are equal does not tell me that it has to be anything. So we are going to have none for a must be. My quadrilateral has one right angle. Well, this statement is very, very broad. So for must be, we have none. For could be, we could actually write any quadrilateral. My quadrilateral has one pair of equal adjacent sides. So if I think of the quadrilaterals that has one pair of equal adjacent sides, it could be, and remember adjacent means right next to each other, it could be a kite, it could be a square, or it could be a rhombus. But it must be, again, there is not enough information, so it doesn't have to be any of them.